Hi guys, in this video I'll be talking about the FTIR basically depends upon the wagging and stretching movement of the molecules present in a certain compound. Okay, suppose there is a formaldehyde. Okay, how it looks like? Suppose it's a formaldehyde, then it looks like this. Okay, now always remember that the carbon atom and the oxygen atom, if that is present in this carbonyl form in any kind of a compound, it always shows same and identical movement, whether wagging or stretching, with the same frequency. Now what is this? In case of carbonyl compound or this type of compounds, what happens if movement occurs in this direction, either upwards or downwards, something like this? Okay, I'll show you with the help of words. That is known as stretching. That is stretching. And if this oxygen atom that moves like this, like a pendulum, okay, that is called wagging. So what is it? I'm gonna use, suppose this is a carbon molecule, this is an oxygen molecule. Okay, now this is a bonding, this is a double bond. Okay, I'm just trying to make you guys understand. Suppose this is a double bond, this two black pairs like this. Now this one, this black one is a carbon molecule, this red one is an oxygen molecule. Okay, so this is a carbonyl group. Now if there is stretching movement occurs, what happens? This, right? This is stretching movement. Now what is wagging? Wagging is basically carbon compound, it's still, but the oxygen atom, it will move like this. Suppose it's like this, normal form. Whenever the infrared ray that excite this molecule, it will move like this in a wagging movement, or the wagging direction, that is like this. Okay, so this is called wagging and that one is stretching. Now the thing is, what happens? Stretching between this carbonyl group always has a frequency of 2 hertz. 2 hertz, hertz means cycles per second. Remember in your 11th to 12th standard. Now wagging, in case of this carbonyl group, always remember this is a very constant value. The frequency of wagging is 4 hertz. So it means 4 times per cycle. I'm sorry, 4 cycles per second. Now what does it means? It means stretching, if it stretch like this. Okay, suppose this is a double bond, as I have already shown. This is oxygen and this one is carbon. Okay, so if there is a stretching, what I have already told, 2 hertz means 2 cycles per second. So there will be a stretching of 2 times per second. 1, 2. This is called 2 hertz per cycle. Now if you want to see the wagging movement of 4 hertz, means how many cycles? That is 4 cycles per second. So 1, 2, 3, 4. Now this is 4 hertz. of the frequency of wagging in case of this compound specifically. So whenever carbonyl group is present, carbonyl functional group, C double bond O, this group is present in any kind of a compound, whether it's known compound, unknown compound, or whatever it is, always remember this frequency of stretching should be 2 hertz, and this frequency of wagging always remains 4 hertz. It's not like it's 2.5 hertz or it's 5 hertz or it's 6 hertz. It's not like that. Always these values or these frequencies are constant for a particular group of functional group which is present in your unknown compound or known compound. Okay, so with the help of this you can basically plot a graph, and whenever IR means the infrared ray that hit the compound, total compound, okay, total compound. If suppose the IR source that has 1 hertz, the frequency of the energy is 1 hertz. So what happens? Suppose this is a detector. Okay, this is a detector. What happens? This is percentage of transmittance, and that is wave numbers in inverse. Okay, what happens? Always remember, as the stretching frequency in case of carbonyl containing compounds are 2 hertz and 4 hertz is in case of the wagging movement. Suppose if the IR source, okay, that has 1 hertz frequency and it will hit on this compound, obviously this molecule will not absorb any less amount or little amount of the infrared ray. Okay, so all the light or all the energy will be transmitted to the detector. So transmittance, percent of transmittance will be 100 at this time. Suppose the IR source that has 2 hertz frequency and that will hit to this compound. Now this stretching frequency is 2 hertz, as I have already mentioned. So this molecule will absorb all this infrared ray and it will be excited, and there will be no transmission of the ray to the detector. So automatically the transmission or the percentage of transmittance that will be dropped like this. So that will give a curve like this. Okay, so in this way basically the infrared spectrometry that works. This is basic principle, but the actual FTIR graph you all have seen in whether in the journals or published papers like that, or in YouTube or in other educational tutorial videos. Okay, so that is much more complicated, but this is the basic principle of FTIR, how it works to identify an unknown compound with the help of the presence of functional groups into it. Okay, by this stretching and wagging. So basically it actually measures the vibration, okay, vibration of the molecules. It basically measures the vibrations and their movements into the molecules, into the compounds, so that it can predict, not identified, because until and unless you perform NMR, you can't you can't be 100% assurance. There is no assurance that it is a molecule of this or something like that. No, you can predict, okay, it may be this compound, it is partially identified as this compound. Okay, so in this way FTIR basically helps to predict some functional groups and predict the unknown compound you have you have isolated from the natural sources. So thank you. If you like this video, please subscribe my channel and share with your friends.